For most of human history, we believed our solar system was an island. The sun, its planets, its comets and asteroids, self-contained, drifting quietly in the void. If anything lay beyond, it was too far away, too unreachable to ever touch us. The stars were distant, eternal, and separate. But in the last decade, that illusion shattered. We now know our solar system is not alone. From time to time, wanderers from other stars slip into our cosmic neighborhood. They do not stay. They arrive, reveal themselves for a moment, and then disappear forever, vanishing into the black. These visitors are rare, unpredictable, and profoundly strange. The first time it happened, it rewrote the textbooks. The second time, it reassured us. The third time, it broke open the mystery again. And with this third visitor, an object now known as 3I Atlas, scientists are facing a paradox so deep it forces us to question not only how other solar systems form, but how our galaxy itself is structured. It begins with speed. In July of 2025, astronomers working with the Atlas survey in Chile spotted something unusual. At first, it appeared as little more than a faint smudge of light drifting against the star field. But when its trajectory was plotted, the truth became undeniable. This object wasn't bound to the sun. Its path was hyperbolic, the unmistakable signature of something that had come beyond our solar system, from interstellar space. That alone placed it into an exclusive club of only two other objects. But this one was different. It was unbelievably fast. To leave the gravity of your home star behind and travel freely through the galaxy, you need energy, lots of it. That energy translates into velocity, and astronomers measure it in terms of hyperbolic excess speed, the velocity an object retains far from any star's gravitational pull. The first interstellar visitor, Oumuamua, had such a velocity of about 26 kilometers per second. The second, 2I Borisov, was faster, around 32 kilometers per second. 3I Atlas, nearly 58 kilometers per second. By a wide margin, it was the fastest interstellar object ever seen. To put that into perspective, at over 200,000 kilometers per hour, Atlas is moving fast enough to cross the entire Earth-Moon distance in just under 2 hours. This isn't the casual drift of a rock nudged out of orbit. This is the trajectory of a projectile hurled with immense force, perhaps billions of years ago, and only now reaching our neighborhood. Its speed suggests a violent origin, an ejection event from a chaotic young solar system, or perhaps gravitational slingshots accumulated over untold millennia as it brushed past star after star. Some astronomers even speculate that Atlas could be as old as the galaxy itself, a relic from 3, 5, even 11 billion years ago, carrying in its frozen body a chemical memory of a time before Earth existed. But speed was only the first mystery. Its trajectory raised new questions. 3I Atlas was arriving from the direction of the constellation Sagittarius, near the thick, star-crowded heart of our Milky Way. Tracing it back to a specific star system is impossible. Interstellar space is too vast, and its path has been bent too many times by gravity. But one idea has emerged. Perhaps it came from the galactic thick disk, a region populated by ancient stars. If so, it might be a fragment of a world long gone, a shard from a planetary system that formed in the galaxy's distant youth. If true, 3I Atlas isn't just a comet, it's a time capsule. But what exactly is it? From the moment of discovery, the question pressed hard: is this a comet or an asteroid? The distinction matters. An asteroid is mostly rock, inert and silent. A comet, by contrast, is a mixture of rock and ice. As it nears a star, its frozen ices vaporize, releasing gas and dust that bloom into a glowing coma and a tail. Early hints came from pre-discovery images, including some captured by NASA's TESS space telescope. They showed Atlas already active, already venting material even when it was still far from the sun. That strongly suggested cometary behavior. But then came a puzzle. A group of researchers posed a simple but devastating what if. What if Atlas wasn't a comet at all? What if it was just a solid rocky body? If that were true, then for it to appear as bright as it did, Atlas would have to be enormous, far larger than any interstellar object we'd expect to see. In fact, if such massive interstellar asteroids were common enough for us to stumble upon one, the galaxy would have to be overflowing with them. But models of planetary formation and dynamics said otherwise. There simply shouldn't be that many. This paradox left scientists with two possibilities. Either our understanding of the galaxy was wrong, or Atlas wasn't what it appeared to be. The most logical answer was the simplest. Atlas must be a comet, with its brightness boosted not by its size, but by the home of dust and vapor expanding around it. Still, theory demands evidence, and so scientists turned to their most powerful eye in space, the Hubble Space Telescope.
In late July 2025, Hubble locked its gaze on the faint smudge racing through the dark. The images it sent back changed everything. There was the unmistakable fuzzy glow of a coma, a cloud of dust and gas surrounding the nucleus, and stretching away from it, a thin tail of ejected material, trailing behind like a cosmic banner. Atlas wasn't just a comet, it was a very active comet. By analyzing the brightness of the coma, scientists could even estimate the size of the solid nucleus buried within. Their calculations revealed it to be no larger than about 6.6 kilometers across, and possibly as small as just a few hundred meters. The paradox was resolved. Atlas wasn't a colossal boulder rewriting the rules of the galaxy. It was a small, fragile snowball putting on a bright show. Case closed. Or was it? Because in science, every answer leads to more questions. If Atlas is a comet, what is it made of? This is not a trivial question. Its composition could tell us the conditions of the solar system where it formed. A system orbiting a star we'll never know, light years away, billions of years ago. To unlock this secret, astronomers are preparing for Atlas's perihelion, its closest approach to the Sun, set for October 29, 2025. At that point, Atlas will be roughly 270 million kilometers from Earth, no threat to us, but close enough for powerful telescopes to dissect its light. The technique is called spectroscopy. By breaking the comet's light into its component wavelengths, astronomers can read its chemical barcode. Each molecule leaves a signature: water, carbon monoxide, carbon dioxide, methane. The ratios of these elements will act as clues, pointing back to the temperatures and pressures that existed in the protoplanetary disk where Atlas was born. Hubble will play its part, but the real star of this effort will be the James Webb Space Telescope. JWST's near-infrared spectrometer is perfectly suited to this task. With it, scientists hope to glimpse the true recipe of an alien comet. Will it look like the icy wanderers of our own system? Or will it carry a fingerprint of chemistry utterly foreign to us? Proof that other solar systems form their building blocks differently. Each molecule Atlas sheds is a word in a story that began long before Earth formed. And as we gather these stories, patterns begin to emerge. Oumuamua in 2017, strange, silent, accelerating in ways we couldn't explain. Borisov in 2019, familiar, textbook cometary behavior, a relief after the mystery. Atlas in 2025, active, ancient, fast beyond expectation. 2 comets, 1 enigma. The odd one out still is Oumuamua. It remains the most puzzling of them all. No coma, no tail, yet an unexplained acceleration away from the sun. Was it venting hydrogen or nitrogen ice in a way invisible to our telescopes? Was it a loose clump of cosmic dust, so porous it was nudged by sunlight? Or, as Harvard astrophysicist Avi Loeb controversially suggested, was it artificial, a thin engineered solar sail drifting between the stars? Most scientists lean toward natural explanations, but with every new discovery, Oumuamua refuses to fit the mold. And that, perhaps, is the greatest lesson of these visitors. Some things will be familiar, others will defy explanation. Both remind us how little we truly know. What we do know is this: Atlas is an ancient traveler, older than our sun, carrying secrets from a star system we will never see. It is moving faster than any interstellar object we've ever witnessed. And thanks to Hubble and JWST, we will soon taste its chemistry. Molecules that condensed in a disk of dust and gas, maybe billions of years ago, only to be exiled, wandering through the dark until it found us. For all of history, we thought our solar system was isolated, that it was an island. Now we know better. There is a highway through our skies, a cosmic thoroughfare where fragments of alien worlds occasionally pass, offering fleeting glimpses into the wider galaxy. We are not alone on our island. We are a port of call. And as Atlas speeds away, beginning its long, lonely journey back into the void, it leaves us with the unsettling, exhilarating certainty that the universe is not quiet. It is alive with travelers, and we are only just learning how to listen when they arrive. Because one thing is certain: Atlas will not be the last, and the next one might change everything. That's it for today's journey through the cosmos. If you enjoyed exploring with us, don't forget to like, subscribe, and hit the bell so you never miss a new entry in the Space Diary. Until next time, keep looking up.